Okay, so more people coming. Okay, so question number 145 points. Again, this exam, up to the midnight. There is just time permits for the people who are actually from outside United States for the late submission. So anyway, we are 45 point for the question number 1, 15 point for question number 2, 40 for question number 3. So far so good. Now the whole entire total thing is going to be 100 points. I'm sorry, this is not 50, it's 100 points. Okay, if you calculate them, it's going to be 100 points. Show all your work answer without supporting work will not be given credit. Now let's move forward to the first question. First question, design a 64-bit full adder using Gen-var and for loop. Be sure to use the parameter on building the circuit. So when I say design, it's not even just writing code, design. That means, you design a 1-bit full adder, make the design like 2300, Then, you will, after you design and you put the blocks and everything, you will go ahead and say that, you will write whatever you designed using Verilog as a hardware description language. Then you're going to make a test bench for this. So now question number 1 is clear?
Sir, just to clarify, for part A, even though it says we use Gen-var and for loop, it's just the design, the schematic, correct?
Yeah, it's not just schematic, design. Normally
for part A,
how we design.
Okay, but we show you the Gen-var and the for loop in part B, correct?
Exactly. But when I say design, but I mentioned Gen-var and for loop because you're gonna use it later. But design. What does it mean, design? Truth table, you put them together, gonna be whatever. I didn't mention, so it's up to you. But I would recommend to be structural for sure, and it has to be mixed between of them, right? Because Gen-var for loop, it's something used by both of them, right?
Yes.
Do you agree? Ashley asked, do we have to draw out 64 full adder? It's not about drawing, how you design a full adder. Do you remember, from 2300, how did we design a full adder? We made 1 bit for that. Whatever, if I give you the answer, then, that's not a quiz, But, at least you understand what I'm saying, Do you remember how you designed it?
Yeah. Mm-hmm.
Okay. Then, question number, and I left you how many pages, so keep it as it is.
Professor?
Yes.
For the first question, do we assume that we have enough switches to implement the number? Or we use that as only 16 switch on the board?
No, there is no board here. It's just a design something. I'm not talking about
so we can assume that whatever how many switches we have, right?
There is no switches. You're writing a code for designing something, right?
I mean, for the input, if we use switch or not.
I mean, if you want to go through full implementation on board, yes, but I didn't think implemented on board. I said just design.
Okay, sure.
Okay, anyway.
Sir, Professor, I had a quick question. So when we scale up from the 1-bit full adder, do you care how we scale up to the 64-bit? Because there's different ways to scale it up.
You can do whatever you want. I mean, what is the optimum way you can do it?
Yeah, that's what I was gonna say. If I could just iterate it 64 times, is that okay?
I mean, it can be. What does it mean to use Verilog as a HDL? It's just saying it's instantiate the 64. Yeah, I mean, Verilog is HDL language. So what I'm asking you to use the Verilog as a HD language to describe that mean, you're gonna make the module and sub-module, instantiate modules and all of these things, That makes sense?
Professor,
yeah.
For the full adder, are we restricted to using only NAND blocks or can we use other logic gates?
It's open, it's design. You know, I didn't specify something. If I want to make it hard, I can say, oh, design it using multiplexer or designing using NAND gates, you know. I just say design, you know, I made it open. So what is the outcome out of this question? You know, you are showing me that what is the steps you have to follow for designing, literally clearly, and then, you know, you will go ahead and you will use the gen var and for loop, right? And then you're gonna test bench. That means, you know, when you write test bench, of course, I'm expecting that you're gonna put the corner cases, right? Why people write test bench? Christian, what do you think? You know, why are we actually writing test bench?
Test the corner case if there's
the corner cases, right? For the test
yes,
bench.
I mean to stress on the corner cases and to check whether there's something wrong happening or not, right? So that means, you know, while you are writing the Verilog for describing the test bench, before that you're gonna make like a 2-3 lines saying that, you know, what are the corner cases you are trying to test, right?
Yeah, that makes sense.
Makes sense. And, you know, if you notice, I left you here an empty area, second page empty, third page empty. Let's say that, you know, one of you finished everything in one page, leave the two other empty. Because, you know, the AI models is scanning these documents will be confused and might give you 0. So you have to be careful because, you know, first iteration, you know, I send it automated to the AI. Then the AI automatically will just like record everybody answers. Then the second step, AI will start looking to all of you guys to check whether that's, you know, anybody have been doing the same thing or not. And, you know, whether that's, you know, some cheating happening or not. And then it will report, print a report. And then I will go manually to check whether this report is correct or not. So be careful, you know. Dedupe. Anyway, now the second question is straightforward, right? It's just a bunch of definition. What is the setup time mean? What does the whole time means? What does the setup time violation means? What does the whole time violation mean? What does the slack mean? You know, you should know. It's a straightforward thing, right? Then, you know, this is very easy question, right? A certain circuit, and I'm asking you to put the static timing passage. It's a quiz. I'm not gonna make it like a midterm, you know what I mean? You understand? Yes.
So for the last question, it's just a passes, not
you're gonna put them 1, 2, 3. Don't make like, you know, whatever, comma, you know? You already have
we don't need to output like how many nanoseconds from A to Z, stuff like that?
Why?
Or we do?
No, my question, why? Why will we need timing here? I just need what identify the static timing path, the path.
Okay.
In the following circuits. Do you think we need any timing?
No, just a passes. I just want to clarify.
No, you're fine. Okay. So, any questions so far? Oh my gosh, there's more people here. So, question number 3. Any questions so far about it? Hello?
No.
Hey, Professor. Quick question. This is actually from, sorry, I just got in. For number 2, does it go hand in hand with number 1, or is it like its own, like, do you want us to just answer like, oh, what is the setup time and what's a...
Yeah, a definition. You know, it's
just
not
a definition.
So what is the definition of the setup time? What is the definition of the whole time? What is the setup time violation? What is the whole time violation? What is the slack definition? You know.
Okay, got it.
But you know, definition in a way that, you know, I fully understand that you understand.
Right, of course.
And
thank you.
You know, that it's not just like, you know, copy paste something. You know, it's basically like, you know, why setup time is important, why whole time is important. The main definition like this. But, you know, in real life, why it's important. So, you know, that's why, you know, and if you notice, everything is already pointed with breaking up, like, you know, 3 point, 3 point, 3 point, total 15, right?
Mm-hmm. Okay, got it.
You know, since you are not here, you know, question number 3, there is no need for any gates responding time because, you know, I'm just asking for path.
You're just asking for math. Okay.
Yeah. Right.
Okay.
And then the first question, I'm asking for the first to design. So that means that's a 2300 practice, right?
Right.
This goes 2300 with syntax, So basically, you design, and then after you design, you're gonna use the gen var and for loop, which are two concepts we already learned. You remember in the Verilog to describe this in a module. You can make it like you can make a sub module and you instantiate it, you wrap it, whatever it's gonna be, and then when you try to answer C, you have to identify the corner cases first. So you say that based on this, the corner cases are the following: 1, 2, 3, 4, 5, 6. And from there, here is our the test bench. And then, you will point out exactly where is the corner cases will be fitted and, how did you cover it.
Okay.
That makes sense?
Right. So, yeah, that makes sense. Thank you.
Yes. So again, I'm stressing on this. This is a quiz. It's not exam or midterm or something. It's just like, something quick. So that's why, maybe if you notice, what is the most heavy questions that, we have so far in those 3 questions? The first one, right?
Yeah, I would say the first one.
Yeah, the second is definition. The third is just identifying path.
Okay, sounds good. Thank you. Yeah, sounds good. Thank you. No, thank you so much.
Yeah, fine. So the rest of the people, is there any questions so far?
Oh, Professor, I have a question. I was wondering if you will move the lab to next Monday, because next Wednesday we actually have off for Veterans Day.
Do we have Veterans Day next week?
Yeah, Wednesday the 11th we have off. So could you push it to like the 16th or 18th?
Let's move it. So gonna be Monday, but it's gonna be the first, and still we're gonna have a lecture.
Okay.
So every team gonna show it to me in what, maybe 5 minutes or so, and then after that we'll have a lecture.
All right, sounds good.
What I can do, I can give a lecture first, and then I can say, okay, let's break it up. I think that's gonna be more sense.
Okay, so Monday we'll do lecture and then lab
lecture
after.
In the beginning. We already have a big timeline, right? We have like from 10 something to 2:15 or something, right? So we have a big amount of time, right?
Yeah.
So okay, Monday. So your due gonna be Monday, November 16th.
All right, thanks, Professor.
Everybody hear it, or should I write it? Wait, CVB. Even 16th, right? We are going to have a lecture. Okay, any other questions? Any questions? Any concern? Shad, do you have any question?
No questions, Professor.
Danush, do you have any question? You are most welcome, Shad, anytime,
No, Professor, you answered everything. Thank you.
Okay. So if we don't have any questions, I can say that, I want you guys to focus now on what? Doing your best. One of the things I want to say, do your best on organizing your answer. Listen, we are engineers. What does it mean? The best, I'm engineer, my office is not that organized. That's fine. But, when I write a report, it has to be very clear. Consider this a report. So I want you to do your best on defining every single thing, writing every single thing, if I am you, right, I can actually use the Word document and I write using words. Don't bring it out and, write with a pen and take a picture, because, that's really hard for the AI model. And, we are computer engineer, I believe. So we should do our best on using the computer for helping us, right? Let's say one of you would like to add the screenshot from the Vivado, for instance. Appreciate it. Let's say somebody, would like to put the waveform supporting the test bench. Also appreciate it. We are no longer in the physical class. We are now in the virtual, and also, practical life is not just like you write in a piece of paper. Practical life, you are using it Vivado, right? That's a practical life. So, I'm trying to make it practical as it's practical, It's not like, everything in theory. So everything is clear?
Actually, I didn't know that we can use Vivado for this quiz.
Go for it.
Oh, okay. I also didn't know we could write it on Google Docs or something. I thought it had to be handwritten. Okay, that's great, actually.
I mean, we are computer engineers. I'm not sure how many of the people here are electrical. Anybody here is electrical engineer?
Me, I'm doubling both.
He's computer engineer. Electrical, Chad, it's also great. I was electrical. So, I was electrical, So what? But then, I did my PhD in computer. But anyway, so in general, what I'm saying that, we are ECE. Don't worry about electrical or what. We are ECE engineers. That means, even in electrical engineering, right? You have to write everything in a very nice way, organize all of wave path. If I'm you and I would like to answer this quiz, what should I do? I would bring a piece of paper and I write what exactly the spec. If you want to show me, that your way of thinking in the first page, there is no problem. Then, you'll move forward to the realizing your plan. Then, you'll move forward to put the conclusion. So, when people will start looking to say, oh, he's really amazing engineer. That makes sense? So do your best. You have until midnight. So do your best. Sounds good?
Sounds good, Professor.
Thank you. I appreciate it for everybody. And, I want you guys to stay safe. God bless you. And I'm sure that you guys, all of you are really amazing and great. And I trust you. And I know that you're going to do your best. So I will see you on Monday, right? Yeah, I'll see you on Monday.
Yep. See you Monday, Professor. Thank you.
I'll see you on Monday. We're going to be talking about what? The UART. Okay.
Sounds good. See you then,
Have a
Professor.
wonderful weekend. Stay safe. God bless you guys. And, Danush, you can stay because I want to talk to you. Thank you, guys. Thank you. God bless you. Thank you.
Thank you, Professor.
Thank you.
Thank you, Professor.
Thank you, guys.